But with that, we'll go ahead and get started. I'll introduce. Oh wait, I'm on the wrong screen. I'll introduce Elia as well, who was going to be here with us. But just to give you an idea of what her career is like, Elia Nunez graduated from American Senior High here in Miami, and she went to the school to college at the University of Miami and got a bachelor's degree. And she has since worked, to give you a flavor for the type of jobs you could have, she's worked with private engineering firms. She's worked for various cities, City of Miami, Town of Miami Lakes, Miami-Dade County. I see that Nicholas, good morning, Nicholas, you joined there in the chat. Barbara Goldman is there in Miami Lakes where Elia is from. We have, she's done quite a bit of work, right, with stormwater, transportation, and currently she's working actually on transit planning. So you all may have heard of the SMART plan here in Miami-Dade County, which is extensions to the Metro Rail, the existing Metro Rail and Metro Mover, getting those extended into different parts of the county. That's the type of work that Elia is doing today, the planning and engineering around that. So that's Elia. I'll introduce myself now. I'll be doing most of the talking today and answering your questions. My name is Albert Sosa. I am also went to high school here in Miami-Dade County and went to the University of Miami as well. Got a bachelor's degree in civil engineering, and I also ended up getting a master's degree in economics from Florida Atlantic University. Never really used the economics degree. It's just something I did for my own education as I went along. I've worked mostly in private engineering firms, including today. I work for a private engineering firm called HNTV. And I also worked at the City of Miami for a while in their capital improvements department, which is quite exciting, right? Because I got to work on different types of projects, roadways. I got to work on police stations, fire stations, designing and building those, marinas, like the different boat marinas at the City of Miami owned. I got to design and construct those as well. So that was a fun job. I actually liked it quite a bit. Today, where I am working on some toll roads here in Miami-Dade County. Like some of the roads that we have here in Miami-Dade County are paid by tolls. State Road 836, State Road 874, State Road 924, a few of those. So I work primarily on those, on the design and planning around those. So that's kind of where my career is. In the past, I did quite a bit of construction administration. So I spent quite a bit of time in the field building things. So if you all have ever been to the airport here in Miami, where you rent the cars, right? It's a building right across the street from the airport where you rent the cars. I was in charge of getting that built. So it was quite an exciting project for me. Guys, as we go along, if you have any questions on any specific topic that I'm talking about, ask it in the chat and I'll work it in as I go. We should be interactive here as much as we can. So what I really wanted to talk to you guys about today is what exactly is engineering and what jobs are out there, right? Because a lot of times people don't always recognize what engineering is exactly and what kind of jobs are available. So I really wanted to talk to you guys about those different types of engineering and what kind of jobs you could get in those and things like that, right? And who the employers are. So I was just going to spend time on that. Basically, engineering is applied science, right? Everything that you learn in terms of science, math, physics, the application of all of that, right? Like what you actually use physics for, what you actually use math for, what you actually use science for is engineering in some way or another. So it's really an application of all of those textbook type of subjects that you learn in school. There's a number of fields in engineering, and there's many more than this, but they basically get grouped into these types of categories. I put civil engineering off to the right because that's what I do. So I'll be speaking about that a little bit more later. But I'll start by talking about the different fields of engineering that you might come across and different careers that you can explore. I'll start with mechanical engineering, right? So mechanical engineering, it's applying engineering and physics and math, like we talked about, and material sciences to develop mechanical systems, right? So think about the air conditioner at your house. Think about the engine that's in a car. Think about different manufacturing type of equipment, weapons and defense as well from a military perspective. These are all things that mechanical engineers work on. So anything that's like a machine, right? That's where the word mechanical comes from, right? So anything that, think about that. Anything that's like a machine, that's something a mechanical engineer would work on. The trends that you're seeing in this industry today, you'll see it common throughout, right? It's a lot of automation, a lot of robotics, a lot of sensor type work, right? So whereas in the past we see things with our eyes, we try and interpret what we see. A lot of that is becoming much more machine based, right? So it's really creating sensors to allow machines to see and interpret the world around them, right? That's a lot of the trends that we see now. Different employers that you can see with mechanical engineering would be Florida Power and Light, the aerospace industry, NASA here in Florida, right? Department of Energy, Department of Defense, other military type applications, right? So missiles, that type of technology that's used by the military is definitely within the purview of mechanical engineers. Electrical engineer would be the next field to talk about. So electrical engineer is engineering is related to electrical components, from microchips, right, which are tiny, all the way up to nuclear power generating stations, right, which are huge, right? So it's and everything in between there too. So telecommunications, like your cell phone, computers, any kind of power system. Like the lights turn on in your house, right? So like how did that happen? It's electrical engineering went into that. The trends in electrical engineering that you're seeing are a lot of battery and wireless charging type of technology. So when you think about electric vehicles, right, battery vehicles, Teslas and other vehicles like that, the battery technology that goes into it is really starting to be developed a lot further, right? So electrical engineers are very focused on that right now. Increasing the mileage, right? How far you can go on a charge in a car is really critical. You've all heard about 5G networks, and those are getting rolled out across the country. Now they're talking about 6G. So it's the next generation is always coming. Jobs in electrical engineering would really be focused on the software and hardware, electrical and programming that goes into robotics, goes into manufacturing, again, weapons and defense systems, lighting, right? So lighting in a house, bringing power to a house, bringing power to businesses and things like that. So different employers here in South Florida, there's a lot of them, right? Motorola, FPL. If you go a little bit further afield, Apple and Intel would also be the type of employers you'd be looking at. Department of Energy, military type of applications, again, different cities and municipalities. So as we talk through this, you'll think through like, in a way, like mechanical engineers, electrical engineers, civil engineers that I'll talk about later. They also work on building structures, right? So like your house, your school building, any kind of building that you go into, it's basically electrical, mechanical, and civil engineers that work on that in conjunction with architects as well, right? So that's the type of application you would see with this. Environmental engineering, that's another branch of what we do. Basically, it's concerned with protecting the physical environment from environmental effects. So sea level rise is a big topic today, right? Climate change. And along with that comes additional storm systems, weather patterns. And also, it also has to do with, in the past, I guess we were not as careful as we should have been as a society with waste products, whether it was human waste products, whether it was industrial waste products like chemicals and whatnot. They would get dumped into rivers or just get dumped on the ground. And that ends up affecting the environment. It ends up affecting ourselves, right? Because our drinking water ultimately comes from the ground. It affects the environment, birds, fish, et cetera, things that we rely on and things that are nature in and of itself gets affected. So environmental engineers are focused on protecting that and really coming up with solutions to make sure that we are not affecting our environment. And we're cleaning it up also, right? So hazardous material and contamination cleanup, drinking water, wastewater treatment. And again, those topics that are trending right now, it's resiliency, it's sea level rise, it's conservation. A few years back, there was a hurricane that went up the coast and ended up hitting New York City. and they just weren't prepared for it. And the sea rose to a point there around New York that it flooded the subways, right? And that became a big problem. So when you hear sea level rise, the other term you hear is resiliency, right? Like, so you're designing things that are resilient enough to withstand that. And Jackie's asking about biomedical engineering. We got that coming up too. So we'll get to that, Jackie, in a second. Job types, again, water and wastewater, environmental conservation, renewable energy. Companies down here that employ this type of engineer would be Florida Power and Light, the Miami-Dade Water and Sewer Department, the South Florida Water Management District. So in terms of rainwater and collecting that and storing it and managing it, the water when it rains to make sure we don't flood, that's South Florida Water Management District. And again, cities and municipalities. And with all of these, there's private consultants like myself. I'm a private consultant working for a private firm, but I end up working on these projects with all of these different types of entities. So Jackie, here you go for biomedical engineering. Biomedical engineering is actually really, really interesting, right? So it's a relatively new engineering field. When I say new, it's decades old as opposed to hundreds of years old, right? So some of these other engineering things are 50 years old, 100 years old, hundreds of years old. Biomedical is relatively new, and it's focused on medical applications, engineering in the medical field, right? So any kind of orthopedic, any kind of prosthetic arm, prosthetic limbs, right? Back in the day, prosthetic limbs were very rudimentary, right? Didn't have any kind of motion. Today they're making prosthetic limbs that actually move, and they're being triggered by nerves in your arm, for example, to trigger a prosthetic hand. Robotic surgery, right? There's a lot more robotics that's going into surgery to minimize the need for invasive surgery, right? By using robots to really get in there without having to get a human inside the body through a smaller incision, for example. Medical imaging, right? Like, so when you hear about an athlete that sprained the knee and they're checking if there's any like a torn ACL or something, they get an MRI, right? Of like magnetic resonance imaging of their ACL to see if it's torn. That type of equipment, CAT scans, MRIs, that's all created by biomedical engineers. It's a lot of different types of jobs you can get with this, right? You can get into research and development. You can get into medical device design, prosthetic design, right? Those are the obvious ones. But you can also get into pre-med, right? There's a lot of folks that want to have a technical background prior to going to medical school to be able to be in a position to apply advanced technologies to their medical practice. So you'll see more and more pre-med type of individuals doing biomedical engineering as a bachelor's degree. It's a very interesting field. I recommend it. It's really growing, right? And you have those types of jobs down here in South Florida, Johnson & Johnson, Medtronics, the old Cordis, right? That those are all folks that are down here that are, for example, pacemakers, right? Like to help your heart beat. The machinery that goes into that, that's really big in South Florida in terms of the research and the development around that. University of Miami has a very good biomedical engineering program here in Miami. Chemical engineering, here's another one that people don't always think about, right? So it's taking everything we talked about in terms of physics and math, but also chemistry and biology. And it's to produce things, right? So if you think about it, when you put lipstick on in the morning, or you brush your teeth at night, the amount of engineering that goes into those products, the lipstick itself, the toothpaste itself, it's an incredible amount of engineering, right? So it's not just the tube that it comes in. It's also the fact that, for example, in this case, toothpaste has to flow out of the tube, right? It has to be solid enough, it has to be liquid enough that you can push it out of the tube, solid enough so it doesn't fall off your toothbrush, and it has to carry the chemicals that are being used to clean your teeth along with it, right? So a lot of engineering goes into that. Contrast that with lipstick. Lipstick has to be more solid than liquid, but it still has to transfer a chemical and a coloring onto your lips in order to carry the product, right? So dishwashing detergent, right? Like it's amazing the amount of engineering that goes into the dishwashing, the dish soap that you use at your house. Again, it has to clean, it has to bond to water, it has to bond to oil, it has to do a lot of things and do them well, right? So there's a lot of need for chemical engineering. The oil and gas type of field, exploring for oil and that kind of thing is super critical to have chemical engineers. Getting oil out of the ground isn't as simple as people think. It's not just, I mean, on the TV, sometimes you see in those old West shows, like they drill a hole and oil starts coming out. That's not really how it works. A lot of engineering goes into they actually have to send pressurized water down the hole to kind of increase the creases in the rock that's down there. And then that water slurry keeps it open a little bit, and that allows the oil to come out or the gas to come out. Then you have to recover it and process it, right? The oil that comes out of the ground it's oil, it's crude oil. You have to convert that to everything from gasoline, diesel, kerosene, lacquer thinner. Believe it or not, the tires on your car are actually a product that is manufactured from oil. So a lot of things come out of the oil and gas, a lot of polymers, a lot of plastics. They come out of that field, and it's just a lot of chemical engineering. And this is another field that's really, when you look at the engineering fields, the ones that pay the most coming out of school, chemical engineering, biomedical engineering, these two are very high paid coming out of school. Aerospace is another one. You'll have airplanes, rockets, missiles, the propulsion systems, the aerodynamics that go into it, the wings, all of that is being worked on by aerospace engineers. Employers down here include Boeing, Lockheed Martin, Pratt and Whitney, which is up in Palm Beach, has a big presence here in Florida. And then you go up the coast to Kennedy Space Center. There's a big infrastructure. There's big infrastructure there and jobs around this type of engineering, satellites, building satellites, designing rockets, that kind of thing. So that's a big one also to keep in mind. Industrial engineering is very focused on the manufacturing process, right? So, and all these engineers, the engineering fields are all tied together, right? It's not to say that if you're an industrial engineer, you'll never work with a mechanical engineer, or you'll never work with an electrical engineer. We overlap with each other. Industrial engineers are very focused on the process. So a mechanical engineer may be focused on the robot that's on the assembly line. The electrical engineer may be focused on bringing power and sensors to that robot. An industrial engineer is focused on lining up those robots and designing a process for all the robots to work together and actually manufacture that final product, right? So a lot of that type of thought goes into industrial engineering, as well as even like freight logistics, getting stuff out of the plant and getting it to a store. Industrial engineers are involved with that. Then I'll spend a little bit of time on civil, which is what I am. I'm a civil engineer. That's what I graduated in, and I'm actually specialized in transportation engineering. So civil engineers can work on a lot of projects, right? Like houses, buildings, parking lots, you name it, right? I'm focused specifically on transportation. And the reason, it's interesting, right? Transportation, you're always going to need it. You're always going to need to get somewhere, whether it's to your work, whether it's to your school, right? Like when you all go to school, maybe not necessarily this year in the COVID environment, but in another environment, when you're going to school, right? You didn't just wake up at school, you had to get there, right? So everybody's got to go somewhere. And that's why I felt transportation engineering was really, it appealed to me. It was really important to me. So it's something that I'm focused on. So when you look at what we do as civil engineers, we work on highways. So whenever you're out on a highway, that's work that somebody like me worked on, designing the asphalt, designing the concrete, designing the guardrails on the side. You look at this picture here, the first thing you see is this light pole, right? So there's electrical engineers that work with us on bringing power and setting up these lights along the highway as well, to give you an example. There's also bridges, right? That's another important thing that we do. I don't know if any of you all have seen the new bridge or have heard about the new bridge that's coming in here downtown, in the downtown area by the Adrian Arch Center. So that's a signature bridge along 395, close to like where the museum park is. And the bridge that you see in this picture is a cable stay, right? So it's actually along that arch, there's actually cables that come down and hold up the bridge from that arch. This type of bridge is good when you want to get something traveling underneath it, right? And there's different types of bridges. Some are simpler, some are more complex. The one that's being built here in downtown, I mean, it's a $600 million bridge project, right? So these projects are big. They're not small things. When you look at that bridge project here in downtown, it's a similar concept to this cable stay, but instead of being cables that hold it, it's actually concrete that hold it in place. But that's going to be a great bridge when it opens up in 3 or 4 years. If you have a chance to come downtown, take a look at the progress. They're really starting to make progress on it. It's interesting. The other thing we work on is tunnels, right? Sometimes you can't get around a problem. You got to go through it, right? So we build tunnels. I don't know if any of you have taken like a cruise in the past, where if to get to the seaport, now you go through that tunnel underneath the bay, right? That's pretty new here to Miami-Dade County. That opened up back in, must have been like 2012 or so, I think. Right? Yeah, about that. So about 8 years ago, it opened up. All that traffic, not just the cars for the cruise ships, but also all the trucks that pull cargo in and out of the seaport used to have to travel on the surface streets, right? Like the streets of downtown before they got on a highway. And it was a huge traffic problem. So putting those tunnels underneath the bay, it was a big project, right? That almost cost $1 billion to do. $1 billion with a B, right? It almost cost that to do, but it took so much traffic off of the local roads that it was a great project, and it's made a big difference to the quality of life here in downtown. You all might also be hearing a lot about tunnels lately with the Elon Musk, right, and the boring company, as they call it. They have an operational tunnel in Las Vegas. Short, it's not very long, right? It's less than a mile long, I think. And they actually run their Tesla vehicles inside on an automated basis to shuttle people around between the convention center and some of the hotels. There's been a lot of buzz here in South Florida lately with the Boring Company and Elon Musk, with the city of Miami mayor, the Broward County mayor. They're talking about bringing that type of technology here to us, where the tunnels become smaller, right? Like the Seaport Tunnel is these huge tunnels because you got to get these big trucks through it. You know, what they build are smaller tunnels, and they only accommodate a passenger vehicle, right? Like a Tesla. But that's okay, right? You're going from point A to point B, and the tunnel doesn't need to be that big. It basically functions like a Metro Rail or Metro Mover type of solution. So that's being discussed here in South Florida now. It's kind of exciting for all of us that are involved in that kind of thing. We also work on airports. That's not the planes themselves, right? But the runways, the terminal building, right? Like when you actually go to get on the airplane, you're inside a terminal building. That's the type of stuff that we work on as well. If you think about a terminal building, there's a structure to it, right? So we work on that. But there's also electrical components to it with the lighting. There's also mechanical components to it with the air conditioning and other components. So, we do a lot of work at airports. It's a little bit different than a road, right? Those planes are heavy, and when they land with an impact load. So the pavement out there is really thick. Like you have to design pavements that are 2 feet thick to accommodate these up to 2 feet thick to accommodate these airplanes, as opposed to a roadway, which might only have 6 inches, for example, of asphalt. We also do a lot of work on transit and rail. So, my colleague Elia that was going to join us today, her focus right now, as I said earlier, is transit, right? It's extending Metro Rail. They're talking about extending Metro Rail, or projects that she's working on, extending Metro Rail north along 27th Avenue. They're extending a monorail out to the beach, right? So from downtown to the beach, there's an extension as well that's being developed right now, and that'll be in place in a few years. So as we become more and more urban, right, and it's very congested, right? It's sometimes it takes us a long time to get places because there's so much traffic. So having a reliable transit solution that kind of avoids the traffic is really helpful, right? So Miami wants to be like, um, Miami tends to be like, we want to be like New York or Chicago that have extensive subway systems or elevated train systems to really move people around that way, as opposed to not having to do be stuck in traffic on the highway, for example, right? So that is what one of the other things we're working on. The other thing that's really innovative today is the amount of sensors and the amount of machine vision that we're putting into our infrastructure and our cars and our vehicles. So it's the concept of having a digital twin, right? So whenever you walk around a location, right? You're walking around an intersection, right? Here, if you look at the screen, what you're seeing is train tracks in the middle and two different roadway approaches coming from the sides and from the top. When you walk around and you see that, right, your mind understands what's happening, right? So your mind processes, your brain processes, okay, my eyes are seeing this, I understand what's happening. For a machine, like for an automated vehicle, for example, it's not that simple, right? They don't see the same way we do. So we're putting a lot of effort into combining sensor technologies and automated learning and machine learning type of technologies to build basically a digital twin of the real world. So whenever an automated vehicle approaches an intersection, it's able to see things in a three-dimensional way, not just a picture, right? It's able to see things in a three-dimensional way and interpret it, right? And understand that I have a railroad ahead, there's gate arms, there's somebody crossing the street over there, there's another car coming. The amount of thought that you give, it's subconscious to you, right? When you approach an intersection, you recognize, okay, there's a car coming, the light's green, so I can walk or I have to wait. So there's a lot of your mind processes that very efficiently. It's not so easy. We haven't gotten there where a computer does that as well. So we're really working towards that to really promote automated vehicles. We have a question about testing automated vehicles. So yeah, here in Miami-Dade County, actually Ford does quite a bit of testing. So they actually pioneered with, I think it was Domino's Pizza, to do the deliveries for pizzas with using automated vehicles. So there's a lot of that testing going on here with Ford here in South Florida, in Miami specifically. And they're getting better and better at it, right? In other parts of the country, Arizona, Nevada, they're doing a lot of testing also. Usually it comes with, there's a driver in the car, but they're not, their hands aren't on the wheel unless there's an emergency. But they're basically teaching the car how to drive. And when I say teaching the car, they're teaching the computer how to drive. And once one computer, it's just basically, it's not every car has to learn, right? It's just the software. Once they get the software to learn, then they can apply that to all the cars. So, so that's those are the types of things that engineers work on day to day. And it's exciting. It's an exciting field, to be honest with you. I like it. When you guys think about high school, right? You're towards the end of your high school. To work in an engineering field, you're going to need a bachelor's degree at a minimum after high school. Master's degrees and PhDs are optional, right? So it really depends on the field. Civil engineering, which is what I do, a bachelor's degree is sufficient. Electrical engineer, depending on what you do, if you're doing roadway lighting, if you're doing residential or commercial lighting, bachelor's is more than enough for that. If you're getting into nuclear power plants, you're going to need a PhD at that point. So if you want to get more specialized in these engineering fields, a master's will be necessary. Even a PhD will be necessary. Jackie's asking about biomedical. Biomedical, you are looking at an advanced degree. So when you look at biomedical fields, Jackie, typically what you're seeing is that the bachelor's degree is kind of broad. And then from there, you go into, if you want to go into, if you did it from a pre-med perspective, you would go into medical school. If you want to be focused on the electronic side of biomedical, you would continue following biomedical and get a master's with more of an electrical type of focus. If you're focused more on prosthetics that are mechanical, you may go get a master's in something that's more in biomedical, that's a little bit more focused on mechanical systems. So depending on which one, but in terms of biomedical, yeah, I would say an advanced degree beyond bachelor's would be recommended. In terms of gaming consoles, like PlayStations and Xboxes, that's your focus there would be electrical engineering, right? That's the type of thing, microprocessors and things like that. There you have a mix. I think in that case, when it's so specialized, what you're trying to work on, which is microprocessors, when it comes to these gaming consoles, I would recommend a master's degree because that is very specialized in terms of the electrical field. If you were not as specialized, like I said before, in terms of residential electric or roadway electrical type of designs, a bachelor's is sufficient. But when you're really talking about specialized fields like microprocessors, a master's is probably recommended. George is asking about industrial engineering. That to me is a bachelor's is tends to be sufficient with that. What you see with industrial engineering is it's more of an application, a process application. So getting your bachelor's degree and then getting out and getting work experience is very valuable when it comes to industrial processes and things like that. So I think industrial is one of the ones that a bachelor's degree is likely sufficient enough. In terms of getting licensed, that's something people talk about, and it depends on the field that you're in. Getting a professional engineering license is important because it allows you to work independently. If you don't have a professional engineering license for like civil, electrical, mechanical, for example, not all of them require it. Like chemical engineering, it's not as important. But for civil and mechanical and electrical, it is important. You can't work by yourself unless you have the license, right? So you always have to work under somebody that has a license. You have to get enough experience, which is 4 years, after you get your bachelor's degree. And at that point, you can take your professional engineering exam. So keep that in mind, right? It's a test and it's a license. It's something. I have a professional engineering license. I've had it for almost 20 years now. And I keep it up every year. I have to take every 2 years, I have to take a few additional classes. George is asking about industrial in terms of business classes. Yes, George, that is absolutely true. So you'll see industrial engineers that actually end up getting a minor in business or getting a master's, an MBA, right, along with their industrial engineering degree. And that has to do with the type of work that you would do as an industrial engineer. It's very focused on manufacturing. It's very focused on the movement of goods. It's very focused on the process of actually getting things built and then getting those things that are built and getting them out to the people that buy them. So yeah, there is a lot of business classes that would be involved in that. Absolutely. In terms of the career skills that you all can think about, regardless of the engineering field, problem solving is super important, right? Because it's all word problems, right? You don't realize it, but everything that we do in the real world it's a word problem, right? It's a problem that comes to you and you have to interpret, okay, what are they saying? What's happening? What's really happening? Do I understand what's happening? Understand it, and then being able to describe it in terms of a series of equations or a series in a way that's a math problem or an applied physics problem. That's really what it takes to solve these types of engineering problems. You don't walk out on the street and see a binomial equation, right? That's not how it works. It's a word problem that then it's a real world problem that you have to write down as a word problem, and then you have to translate that into a binomial equation or what have you. Strong math and physics skills, being able to work well with others. Very few engineers work by themselves. We all tend to work together as teams. I work in an office of 60 people. My team, the team that I work with every day is almost, and there's 8 of us. So we're always working together. And I cannot emphasize enough communication skills. People don't always realize how important that is. I didn't realize how important that was until I actually started working in the field. You need to be able to communicate in writing. You need to be able to communicate verbally. You need to be able to speak publicly to communicate your solutions, right? Because ultimately, whatever you're going to do from an engineering perspective, you're going to have to document that in a report, right? So you have to be able to write well in terms of here was the problem, here's how I solved it, here's all the steps that I took to solve it. So somebody else can come behind you and verify what you did or apply it to a different problem, right? And document how you solved this problem and how it can be repeated, right? So written communication is really important. And then being able to take that written communication and explain it to somebody, right? That public speaking part is really important. It's like, hey, I solved this problem. Here's how I solved it. And then you have to really think about how am I going to communicate that to somebody who's not an engineer, right? So that in a way that they understand it. So being able to think things through and really communicate them well, super critical. When you think about what are those basic skills that you're going to need coming out of high school so that it's easier for you to get a job, maybe when you're in college or when you're coming out of college. The basic, and I use the Microsoft terms here, Word, Excel, and PowerPoint, but the Google Docs and those Google Sheets, right? It's equivalent, right? I'm not trying to say Microsoft versus Google or anything like that, but having that basic Word, Excel, and PowerPoint type of skills is really important. I can tell you in civil engineering, 50% of the math that we do is in Excel. It really is. It's understanding spreadsheets and understanding how to apply them well and how to use them is really critical. Graphical information systems and CAD systems, right? So the different CAD, computer aided design and drafting that you can think of, all of the different engineering professions will use some sort of computer aided design and drafting software. There's different ones, right? Revit, Civil 3D, AutoCAD. GIS, graphical information systems, is basically a way to associate your drawing with a database that contains a lot of data for any specific point in a graphical way. That's important as well. Even things like Photoshop and InDesign, right? Those are really important too from a presentation perspective, right? When you're having to create a document to document what you did and document it in a way that's appealing to people, having those skills in Photoshop and InDesign are important as well. I think this is like one of my last slides. It's about what we're seeing in terms of trends in the industry today in all the engineering fields. The notion of reducing emissions, right? That we're in this carbon economy. We really have to get carbon neutral, that drive towards carbon neutrality and drives a lot of things, right? We're trying to prevent global warming or reverse global warming. So it feeds into everything, right? Renewable energy, recycling, resiliency in terms of sea level rise, right? All of these things are fed off of that carbon economy and reducing emissions. Electric vehicles, it's driven by that. We're seeing a lot of trends in technology as well around 3D modeling and visualization, right? So what you see on the screen here is the top picture on the left there in the middle is it's an actual digital model of a real world mechanical system, electrical, mechanical, right? And it's you build these in the machine ahead of time before you build the facility, right? Like you think about a building, right? It has all kinds of fire sprinklers, lighting conduits, water and sewer pipes, HVAC. It's got all these things. So you have to really visualize it in a 3D model to make sure all these pipes aren't hitting each other, right? And you want to solve that ahead of time before you get out in the field to build it. So that's building information management system is what you have there as a BIM model. Additive manufacturing is also a big deal right now. Additive manufacturing, before manufacturing was basically you had a big chunk of steel and you would carve what you wanted out of it. Now it's the opposite, right? It's 3D printers like you all have in school sometimes. It's you start with nothing and you build it. That's additive manufacturing. That's a new trend. More and more things are being done with additive manufacturing. That's what I had, guys. I know you guys have been asking questions. Andreina, like the first 3D printed house? Yes, absolutely. So there's more and more of that coming out, right? And they're actually, the 3D printers are getting bigger and bigger. So yeah, any kind of additive, that's additive manufacturing, right? So those 3D printed houses, where actually the material is inside the print head, right? And it's laying the material out in the size of a house, and it's, that's really a big trend. Industrial engineering is focused on that. Mechanical engineering is focused on that. So that's a good trend. Reduces waste too, right? Instead of having to start with something big and chipping away to leave you with something small, you reduce the waste by only building what you need. So additive manufacturing is definitely very trendy right now. Any other questions? I think I've caught most of them as they've been going by. Jackie, since you weren't able to see the presentation as it was going because of your glitch, I'm going to go back to the biomedical screen just so you can see what I had up for that. So yeah, biomedical, I'll be honest with you, that was something I wanted to study. Unfortunately, I wasn't quite smart enough. I couldn't get it. It's a lot of math. The biomedical, electrical, a lot of math. So I stuck with civil that was a little bit more suited to my skill sets. These are all exciting things.
And I should point out, Johnson & Johnson actually has an office here in Miami. Mm-hmm. It's been part of the work on the coronavirus vaccine even.
Mm-hmm. Yeah.
And then University of Miami is doing so much with this. And of course, FIU even has a nano lab. You know, it's just really amazing what all is going on.
You're absolutely right,
fields, really.
Yeah, you're absolutely right. Look at coronavirus today. That's a very good example. Right?
Yeah.
The amount of science that goes into those vaccines.
Yeah.
Moderna vaccine, the Pfizer vaccine.
Yeah.
Those are all it's like nanotechnology, right? They're basically creating an artificial way to get your body to trigger an immune response to get you ready for the coronavirus. That is exactly the type of thing that biomedical engineers, chemical engineers work on. The pharmaceutical industry.
Yeah.
It's really about that, right? And it draws. Obviously, they're working with biologists and chemists, right? No doubt.
Yeah.
It's very critical to our world today. Absolutely.
You've covered so much and so many details, I think, too. And I think all of the students who are in engineering, remember how much your teacher talks about the fact that you start with a problem. You know, what's the challenge? And in the real world, you know, those types of things, like our challenge with traffic, our challenge with healthcare, our challenge with, you know, the flooding situation in Miami. These are the types of things that engineers tackle, and we learn so much from all those problems.
Yeah.
Correct, Albert? But yeah, this is really great. A lot of detailed information. You know,
Raffaello, if you could type in your question, that's going to be best. If you could chat in your question.
Yeah. You all, I don't believe, yeah, you can't turn your mic on. I just want to remind the students that after this session, there's the expo, and there are a number of videos in there for you to on and watch. And then they have links out to some of the other information that they have. And then at 1:30, you click on the icon that says stage, and it will probably have the little thing that'll say live up there.
So we have a couple questions coming through.
Yeah, go ahead.
How long have you guys been working in engineering? Myself, 25 years. My colleague Elia, that was going to be with us today, 21 years.
Wow.
But you can, right out of school, you start working right away. You'll be working under an engineer, but you'll start working on real things right away. You know, that's definitely, the need is there for engineers and engineering skills right out of school. Raffaello, you asked about public speaking skills. That's a good question, because you know what? It doesn't come natural. It really doesn't. It's a learned skill. This is going to sound crazy, right? But I don't know, maybe it's going to sound silly. Don't be afraid to take a theater class in high school or college. Don't be afraid to seek public speaking opportunities. So If whenever there's a group project that you all have to do together, typically you guys have to present it to the class, right? Don't be shy and don't be the one to present, right? That you just, it's practice, it's doing it. That's really the only way to improve public speaking skills, is you just do it. There's also another, there's a place called Toastmasters. Not a place, it's like an organization, Toastmasters, like a toast at a wedding, TOAST, Toastmasters. If you look up Toastmasters online, they're going to have regular meetings once a week, once a month, depends on where they do it. And it's an opportunity for people to improve their public speaking skills. It's just like a club that you go and they're organized around helping people improve their public speaking skills. I don't work for them, so I don't, I can only endorse them so much, but I've heard people that have gone to it and they've actually improved their public speaking skills. George is asking, what made you discover your skill sets at college to choose the type of engineering? So, okay, that's a good one. It was classwork. I'll be honest with you, George. For me, the more I got into electrical and biomedical, which is what I was searching for, the math is really intense. And I learned I like building things. Like it just takes a while to figure it out. Originally I started as I thought marine biology was going to be my thing. But when I started doing marine biology, what I figured out is I wasn't interested in the fish. I was really interested in the filters and the pumps and the mechanical equipment that went around like aquariums and closed systems. So that drove me out of biology towards engineering. But then I had all this biology classes I wanted to save the credits for. So I said biomedical engineering, and then I got towards electrical, and then just the math is intense. So I kind of took a step back and I said, all right, what engineering do I have all the math for already? And civil was it. And I enjoy working outside. I enjoy building things. So large scale things, buildings, things like that. So that's what drove me towards civil for sure. So Pam, I think at this point we are out of time, correct?
Yes, we are. It's 12:31. So, yep. Great questions too, and thank you so much, Albert. This was really good for reviewing what the future trends are. Just remember, you guys, there will be all these different engineering opportunities out there for you. So yes, as you leave from here, of course, we've given you enough time for lunch. And then also the expo on the left-hand side, you'll see like the words now, our little red balloon over the expo that says now. And that's where the other things are for you to look at the videos from colleges and also other organizations. And then at 1:30, you're going to select the stage area. So thank you so much for being such a great audience, you all.
Thank you all. Thank you for your questions.
Thank you again. This was really, really great. It's hard to explain, but I think that I think that they've certainly gotten a sense of all the different things that you all affect and do here in Miami. With our highways and bridges and infrastructure and airport and everything.
All of these things they're local jobs. These are jobs you can get here locally. Absolutely.
So thank you again.
All right, everybody, have a good day. I'm going to sign off.
Okay, thanks.
Be good. Thank you.